Hello and welcome to the last video for this series. At least for now, most you're allowed to request that I redo a video, or if you want to cover a different question that isn't covered in the series, drop a comment. Right, we are looking at the last question on paper 1, November 2022 from the department. 10.2, let's go. A 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated. Okay, how many possible 4-digit combinations are there to open the lock? Okay, so there are 4 spaces to fill. We know that in the last place, the code must be even numbered. So and it can't end with a 0. It can't end with a 0. So that means we can only end with a 2, 4, 6, or an 8, right? And then we know that for every other space, we could be using the numbers from 2 to 9, right? Can't use 0, 1. And likewise here. Okay, but that being said, just need to find a different position, right? For each of these spaces, we can't use except number at the end, right? So for instance, if the number ends with 2, then we can't have 2 in either of these spaces. So in fact, you don't have 8 options for numbers over here. You only have 7, right? Because over here, what am I saying? Okay, so there are 8 numbers from 2 to 9. 2, 3, 4, 5, 6, 7, 8, 9. Yes, there are 8 numbers, but there are only 7 available here, because here this will steal one of the numbers that's available. So if this ends with a 2, then I can only use the numbers from 3 to 9 here. Or if it ends with an 8, then I can only use the numbers from 2 to 7 and 9. Okay, so first spot, only 8 numbers are available. Then second spot, 7 are available because 1 has been used up over here. Third spot, 6 are available. And then the last spot, technically, wait, no, I'm lying. There's 4 options over here, right? So yeah, it feels weird to write it this way. Like, I really do want to say there's 1 number that you're using, but there's 4 different possibilities. I don't know. Let's just say there's 4. At the end of the day, there's 4 options over there. And what does that work out to? So there are 1,344 possibilities, right? Memo, right? No, Memo does not agree. Why don't you agree, Memo? Wait. So, in the first slot, we can't use 0, we can't use 1. Oh, and then there's, oh man, there are 8 numbers from 2 to 9, but whatever number we use here is excluded. Oh my goodness, I literally said this and then I proceeded to write the wrong thing. So there are actually 7 options for the first slot, right? It's going to be the odd numbers, 3, 5, 7, 9. And then depending on what number you use here, the other 3 will be available. So there will be 3 even numbers available to pick from, right? And then for the second slot, it will be 1 less from this pool. And then for the third slot, there's 2 numbers that have been taken out now. So only 5 are available to use. And for this last slot, you can choose from 2 to 8. Okay, right, so now 7 times 6 times 5 times 4 is 840. So even fewer possibilities. Yes, now we agree. Yes, we do. Okay, last question. Calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. Okay, so we want to find how many codes satisfy these conditions, and the probability that you guess correctly the first time will be 1 out of however many satisfy the conditions. So the conditions are the code is greater than 5,000, so that means it starts with a oh no. Okay, so again we have 4 slots, so it could start with a 5, 6, 7, 8, or a 9. Okay, and the third digit, okay, we know that it's even numbered from the first question, so it ends with 2, 4, 6, 8, and we know that 0, 1 can't be in the digits, so yeah, it can only end with 2, 4, 6, 8. We also know that the third digit is 2, so there's only one possibility over here, right? We know that that number is 2. Okay, so then over here, what does this mean? How many options do we have? Well, okay, this is also interesting because 6 is only available if it hasn't been used here. And likewise, 8 is only available if it hasn't been used here. So we're actually looking at 2 cases. We're looking at the cases where we have 6 or 8 over here, some other number. This is 2, i.e. there's one option here. And then if it starts with 6, it has to end with 8. Or if it starts with 8, it must end with 6. Now what am I saying? It would be 6, and then the only options are 2, 4, or 8. Or if it starts with 8, then the only options here are 2, 6, and 8. Okay, so over here, there would be 2 options for the first number. Here, what would be in the bag? So we would have, we can use any number from 2 to 9. However, 1 has already been used here, 1 is being used over here, and so that leaves us with 6 options over here. Here we only have 1 option, it's the number 2. And then here, there's 3 options. Okay, so, well, okay, no, I mustn't consider them together because that is confusing for me, honestly. I'm just going to consider them one by one. So, it's this case. Okay, right? And then this again. But thinking about it with 8 as the first number. So then here our options are 2, 6, or 8, but it's, so I'm thinking of them as one option. So I'm thinking of the case where, okay, we start with a 6, then it's going to end with 2, 4, or 8. Here we only have one option, we know the third digit is 1. Then here, what are we left with? Oh, we're not actually left with 6 numbers, right? Because how many numbers? Between 2 and 9, there are 8 numbers. Okay, so over here, we've used up a number here, we've used up another number here. Oh, hectic. So, oh my gosh, so 2 isn't an option here because we can't repeat digits. So actually, we have 2 options for the last slot. Okay, so, right, one option here being 6, because that's the case I'm considering. One option here, 2, because it's the third digit we've been told. Then here, it would have to either end with 4 or 8, so there's only 2 options. Here then, we've used up one number here, and also one number here, right? There are 2 options, but ultimately, we only use either 4 or 8, not both. So here, there will be 5 options left for this slot. Okay, right, and similar here. Okay, so the number of combinations that would start with 6 or 8, that will be 2 times 1 times 5 times 1 times 2. So that is 2 times 10, which is 20. Okay, then the other case, so this is case, oops. Ooh, big burp. So this is case 1. Okay, then the second case is where we have 5, 7, or 9 as our starting numbers. We know that this is a 2. Then the code can end with 4, 6, or 8, right? Because we can't use 2 again here. So then the question is, okay, how many options do we have left here? So 8 numbers to choose from. There's the bag of numbers, there's 8 numbers from 2 to 9, right? 2 is already used up, so that's one number gone. Another number gets used up here, and another number gets used up there. So again, there's 5 options over here. So 3 here, 1 here, 3 here. So that will be 3 times 5 times 3, which is 45. So in total, the total number of codes, well, the probability of first guess being right would be 1 out of 20 plus 45, which is 1 out of 65. So, memo. Dictembil. Memo is coming with other things. Wait, let me just see if I read this question correctly. Calculate the probability. Oh, that's my go-to sleep alarm. Okay, so let's wrap this up. So the question says, calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. And they work that out by saying 65 out of 840. That for me is the probability that the code it satisfies these conditions. If we're saying calculate the probability that you open the lock at the first attempt, if it is given that the code is greater than 5,000 and the third digit is 2, so there are only 65 possibilities. If it is given to who? So, okay, I'm trying to make sense of this. So let's say it is known, not by me, the person trying to hack the lock, but just what are the chances that, okay, this is me really thinking out loud. What are the chances that the combination is a number that is greater than 5,000 and has the third digit being 2. I feel like that's what the memo is answering. Hey, this question is not giving sure. Calculate the probability that you will open the lock at the first attempt if it is given. Yeah, I'm not sure about the given, because if we're talking about me being oblivious to this information, right, then the chances that I open successfully on the first attempt, there's 840 possible combinations, and I am going to try one of them, and that will be the chances of me getting it right is 1 out of 840, because only one of them can be right. And one could even argue that, how much information do I have as a person trying to open this lock? Do I even know that the code must be even numbered and may not contain the digits of 1, and digits may not be repeated? Because otherwise the sample space of combinations that could be tried... Oh, I'm opening another can of worms now. But yeah, like just the sample space relative to me, relative to what I know, would be, there's 10 possibilities for first slot, the number 0 to 9, 10 for the next one, 10 for the next one, 10 for the next one. So it would be 1 out of 10 to the 4, the chances of me getting it right the first time. What are the chances of me getting it right? If I know these conditions, then I know that there's only 840 possibilities. The assumption would be that I would try one of the 840 possibilities, and the chances of getting it right would be 1 out of 840, because again, there's only one that can be right. So my logic would be the same for this question, is that the chances of me opening it at the first attempt, if this information is not given to me, then it doesn't affect the probability of me getting it right. Like, there's still 840 possibilities in my head. Hey, I don't know if I'm making sense. I'm so confused. Because the memo is saying 65 out of 840. I genuinely don't think that that's the answer. Yeah, please, this is definitely open for debate or enlightenment for me. Like, if someone can just explain why 65 out of 840 would be the answer. I genuinely feel like 65 out of 840 is the probability that the lock, the combination, is a number that satisfies these conditions. It's greater than 5,000 and the third digit is 2. And all the other stuff, well, no, okay, never mind. Well, kind of, it is even numbered and all of that stuff from the first question. So yeah, I'm definitely okay with agreeing to disagree with the memo on this one. Yeah, as usual, thank you so much for showing up, and I hope that it's been valuable in all of my confusion and all of my making mistakes. Counting is one of those things that really, it's so easy for me to just like get into a rabbit hole of overthinking and confusing myself. I don't know what advice I have for another me out there. Yeah, I'll have to think about that. But yeah, practice at the very least. It's one of the things that you can do. Cool. Catch you another time.